Welcome to statics. In this problem, we're paying attention to a beam um, that is held up by being cantilevered at A. We're given that it's a compound beam, and we've been asked to find the reaction at supports A, E, and B. And I have a pretty lousy diagram of what's going on here at B, but let's go ahead and magnify it so you can see what's going on a little bit better. So this funny thing going on at B is just a two-force member that goes from B down to this pin. And so when I begin this problem by thinking about the overall free body diagram, and I draw a beam, that goes from A to C to D all the way over to B. That two-force member at B, all it can do is do that. So the whole purpose of this kind of structure going on here is just to indicate that BY, and I'm guessing that it's pointing up, but it could also be pointing down. So likewise, let's go on and finish up the external reactions possible. There's an EY possible here. That's because it's a roller, a rocker. And then over at A, that's the where this beam is going smack into the wall. We have an AY force possible. We have an AX force possible, and we have a moment at A possible. This moment is possible because it's cantilevered. We also must include our external loads. Let's just kind of give them a different color to call them out. So right here in the middle of this 6 meter segment length, we have 2,700 newtons. Likewise, the area of this beam is a half times the base, which is 6 times the height, which I didn't tell you, but it's 900 newtons per meter. And so that is equal to 2,700 newtons as well. So this was 900 newtons per meter. And so we can replace that distributed triangular load with a point load located 2 feet to the right of point D. So right here, if this distance is 2 feet, that's where I would put my 2,700 Newton load. All right, did I get everything? Let me just quickly make sure. So we got AY, AX, moment at A. So we don't, lots of students confuse this, and I just want to sort of highlight this to you by talking about it. So when I'm doing my overall free body diagram, I don't do anything with the internal forces at C and D. I wait on those because nothing is touching them from the outside world. However, on this beam, if we look at the beam, we can see the beam is touching the outside world at A, so we have to consider all these things. It's got those two loads on it, and it's touching the outside world at E and also at B. So that's why we include all these things, but why we don't do anything at C or D yet. All right. Quick look at this overall free body diagram leads me to conclude when we sum the forces in the x direction and set them equal to 0 that AX is 0. Now, let's count up the number of remaining unknowns. So AY is an unknown, EY is an unknown, BY is an unknown, and MA is an unknown. And so that's what I need to find all 4 of those things. And the bad news for us is that in 2 dimensions, I've already used one of my equations there. I only have 2 equations left, which is sum of the forces in the y direction is equal to 0, and sum of the moments are, in the z direction is equal to 0. I only have 2 equations left, and yet I have 4 unknowns. So we have no choice at all. We've got to break this beam up into corresponding segments. And so I'm going to just attack this methodically from the left, working my way on over to the right. So the first segment to consider is segment AC. So if this is point A, that is AY, and this is C. I am now breaking up the forces. These are internal forces, but now that I'm breaking them up, I now draw them in. So remember, AX we'd already found was 0, and therefore CX will be 0. And then the other thing I've got to add in here is my moment and the load. So we have the 2,700 newtons coming down. All right, so I can't make too much progress here yet because I only have 2 remaining equations and I have 3 unknowns, MA, AY, and CY. So I'm just going to leave that segment on hold for a little while. And I'm going to move on to the next segment. So the next segment to think of is the segment that goes from C to D. So let's draw that as the next thing over. So here is my segment CD. That's C and that's D. All right, so I must, this is what's really critical to do in this chapter where we're learning how to break things up. So you must reverse, this is an internal force. And so as we move our way along the beam, I must reverse the direction of that internal force so that the 2 of them added together will disappear and go away. So that's why this is pointing down and that one was pointing up. Likewise, if CX had not been 0, I would need to put that in, but again, it's still 0. So I'm just putting it in for fun now. So that's what's going on at C. Over at D, we can make a pretty good guess that DY is going to be pointing up because something's going to have to counteract that. And there could be a DX, but since CX was already 0, we know that DX is going to be 0 too. All right, so this is where I would like you to just kind of pause a moment and see if you can conclude anything about CY or DY. Some of you may already have realized that this little segment, this segment CD, is a 2-force member. But if you didn't realize it, the equations will help you realize it pretty fast. In other words, if I go ahead and I sum the moments at C and I set them equal to 0, right? What I see is that I have dy times the segment length, which is 4. And that's it, because this little segment here has no load going on in the middle of it. And so what does that mean? Well, that means that dy is 0, right? And if dy is 0, and therefore ay is 0, or not ay, sorry, cy is 0. All right, and so what I'm saying is that that's 0, and that's 0, if I kind of track it back. Well, and so now I want to return my attention back to that first segment now. So now I only have 2 remaining unknowns, the moment at A and AY. So I think I can go ahead and take this a little step further now. So if I write my equations of equilibrium, I can sum the moments at A, set them equal to 0. What I'm going to get is my unknown reaction moment at A, which is positive. We drew it as positive, so we write it here as positive, minus 2,700, and that was a distance of 3 meters away, is equal to 0, and therefore MA is equal to 8,100 Newton meters. And that was one of the unknown things we were trying to find, so hooray, we're making progress. The second thing I can do relative to this segment now is I can sum the forces in the y direction, set them equal to 0, and what I get is AY minus 2,700, CY was 0, is equal to 0. And so therefore AY is equal to 2,700 newtons. All right, we are making excellent progress. We have now found 2 of our 4 unknowns, and we are making good progress on this problem. So let's kind of look back at the beginning. So we had we've done segment AC, we've done segment CD, and now you can see that what's going to be left is to look at segment DB. And before I do that, I want to comment on this. I had this problem on a quiz recently, and some students wanted to draw the section of the beam that only went from C to E. So you can do that. If you do that, though, because E does not end on a pin, and it's and there, yeah, basically because it doesn't end on a pin, what you're going to have to do is you're going to have to draw the internal shear and bending moments by cutting that beam apart at E. On the other hand, if we choose the whole segment that goes from D to E to B, at D and at B, there will be no bending moments possible, and so it kind of eliminates an unknown. So I'm going to choose the segment that goes from one pin to the next, which is the segment DB. And so let's go ahead and do that and draw a free body diagram. So here I am at D, and we decided that dx and dy were 0, so I'm not even going to draw them. We have this force from the rocker, and we have this force from the pin. We have the load of 2,700 newtons, and it is located at distance 1 from EY, and this distance is 3. And we're not forgetting anything, that we're good. So let's just, looks pretty good. We got two unknowns, and we've got 2 equations to apply. So let's go ahead and sum the moments at E, set them equal to 0. I'm going to get By times 3, and that will be positive, plus 2,700 times 1 are equal to 0. And therefore, By will equal minus 900 newtons. So what does that mean? That means that over here, this strange contraption was actually holding, it's holding the end of that beam down. If it wasn't doing that, it would sort of fly up in the air, and it would bend down here at D. So it's holding the beam down. By turned out to be negative 900. It is pulling down. All right. Now let's sum the forces in the y direction, set them equal to 0, and what do I get? I have EY plus BY. EY, now BY was negative, so I'm going to do minus 900, minus the load of 2,700 is 0, and therefore EY is equal to 3,600 newtons. And that was our last unknown, and so we have completed this problem. Again, when you see these compound beams, you take them apart at the pins. Don't take them apart anywhere else. Take them apart segment by segment where they're pinned together. And if you do the first one and it doesn't get you anywhere, just move on to the next one. And if that one doesn't get you anywhere, move on to the next one. And then just between the 3 of them, though, you will get the information you need to be able to solve the problem. Okay, that's it.